Okay, in this video, we're going to be talking about all the extra stuff or all the other stuff for Chapter 4. Not really big topics, but things that we do need to talk about. All right, and the first thing we're going to be talking about is what is called a digraph. Now, a digraph is nothing more than a graph with directional edges or directed edges, or otherwise known as an arrow. Okay. Now notice in this picture how there's no longer straight edges connecting all the vertices, now they're arrows. And please remember also that these type of graphs will always be representing information. I'm just giving you a graph, but usually there would be a backstory behind that. All right, so let's kind of dive into this digraph here. All right, the first thing what we're going to be talking about is what is the in degree and out degree of a digraph. Now the in degree is nothing more than the arrows that are coming into a particular vertex. So at random, I'm just going to choose vertex A. So vertex A, it has an in degree. I'm using my mouse here. So it has an in degree of 2 because there is 2 arrows pointing to it. And it also has an out degree, which we're going to say out. It has an out degree of 2 as well because of the fact that it has 2 arrows leaving it. Okay, so let's choose another at random. So I'm just going to go ahead and choose vertex D. So let me clean vertex A out and clean that out. And let's just say this is vertex D. Now vertex D has an in degree of, I'm going to cross that out, of 1 because 1 arrow is coming to it and then 1 arrow is leaving it. All right, pretty simple. Now let's actually talk about how you create a digraph. And of course, I didn't necessarily refer to that, but an out degree is the arrows leaving it. So, all right, so let's actually talk about how you create one. Okay, now the way you create one is we're going to continue to stay on this is that you have vertices A, B, C, and D, very similar to a couple of videos ago where you had to create a a graph. But in this case, the ordered edges are going to be given to you, but you have to remember that the arrow will be pointing to the other edge. Okay, so or I'm sorry, the second vertex. That's what I was about to say. I'm sorry. It'll be to the second vertex. So like for example, I'm going to highlight A to D just at random. I'm just going to highlight that, and that is this one right here because of the fact that it is going from A to D. So that's how easy it is to figure it out. So let's do an example really quick. Okay, here's my example. Vertices A, B, C, and D and ordered edges A, B, C, D, and AD. What I'm going to do is I'm going to go ahead and pause, or I'm going to pause the video and I'm going to go ahead and get my answer. And let me encourage you to do the same. And then what we're going to do is I'm going to start the video again and we're going to compare our graphs to see whether or not we're right or they match, that is. So go ahead and pause the video right now. Okay, and there's my gra or my digraph there. Hopefully yours matches mine. Now, if I was going to ask you a couple of questions based upon what we have drawn here. So if we were to talk about vertex B, and if I was to ask you, okay, vertex B, what is your in degree of vertex B, which I'll just abbreviate as I, you would say is 1. But what is my out degree? You would say 0 because there's no arrows actually leaving vertex B. Okay, we're going to try one more before we move away from digraphs here. Here's the next problem that we have, vertices A, B, C, D, and E. Go ahead and pause the video and see if you can figure it out right now. And there you have it. That's what your digraph should be looking like. Hopefully yours matches mine. Okay, the next thing I want to talk about is what is called a tournament. And it is also a digraph that receives from giving directions to the edges of a completed graph. You have it right in front of you. Now, here's what I want to focus on, and that is this. Since you are dealing with the, excuse me, since you are dealing with arrows here, this is how you figure them out. All right, losers get the arrow. So what I mean by that is every arrow that you see represents a game. So let's just, at random, choose this arrow right there. So that is a game between A and B. So it's A versus B. Now, if I was to ask you who actually won between this game that's represented by this arrow, you would say that A won. The reason A won is because of the fact that on this digraph, the winners get the end of the arrow. So in other words, the winner is actually pointing to the loser. So A is the winner to where losers got the arrow. There you have it. It's pointing to B. B is the loser. So using this information, and all this information will always be given to you. All right, so it's not going to be anything you're really going to have to figure out. If I was to ask you, based upon this tournament that we've just created, if we had A, B, and C, and if we were going to compare wins and losses between A, B, and C, and let's say wins and losses, we would say that A won 2 times to 0 losses. And then let's look at B. B, they lost 2 times, so they're 2 and 0, or 0 and 2. And then C was 1 and 1 because A or C won a game and they lost the game based upon what's pointing to them and what's leaving them. So that's how you do a tournament. All right, here's another example of a tournament here. So once again, if I was going to figure out, okay, what are the records? So if this is the records A, B, C, and D, based upon the last slide we were just looking at, I'm going to pause the video and I'm going to go ahead and write down my answer. And let me encourage you to do so as well. So when I hit play again, or when you hit play again, we'll be able to compare our answers and check to make sure you're right. So go ahead and pause the video right now. Okay, there is the result of our tournament here. And if I was going to ask, okay, who was the overall winner of this tournament? Well, you would say that it was D. D was first place. D was the overall winner because it has the most wins. And that's how you do a tournament. Okay, the last thing we're going to be talking about is what is called the chromatic number. And the chromatic number is labeling a graph, meaning you're going to take the vertices and you're going to put them into different groups by labeling them or putting them or coloring them. And the one thing that I want to bring to your attention, and that is this: adjacent vertices cannot have the same label. Okay, now that doesn't really make any sense because we haven't done an example. So let's go ahead and just dive into one. I'm going to focus on this vertex right here, okay? And I'm going to remember that each graph, like I said, always has a backstory behind it. So let's just say I graph some information and there you go. So what I'm going to do is I'm going to now sort this information by taking that vertex and actually labeling them, okay? And I'm going to put this vertex here, I'm going to put that in group A, okay? Now, here's what I want you to pay attention to, and that is this: adjacent vertices cannot have the same label, or they cannot be in the same group. So what that means here is this vertex here, see how I put that as A? You can't do that because they're touching each other, to keep it simple. So what that means is this vertex will have to be in a different group. But before we start assigning different groups, let's go ahead and finish out any of the vertex that could be in group A. Now you see this vertex here that I'm going to label an A. Is that vertex adjacent to the other group A? And the answer is no. So this can actually stay A as well. So we're just going with our alphabetical grouping here, labeling. I'm going to call this group B, and this right here could be in group B. So if I was to ask you how many different labels did you use for this graph, well, the answer is 2. Let's try another one. So here we have this graph right here, and that we are going to go ahead and label. So I'm going just to start at random, and I'm just going to say this right here will be group A again. Now remember, if you're going to put anything else in group A, remember they cannot be adjacent to this vertex here. So I'm going to choose just at random this right here. Now, of course, someone might ask, well, couldn't you have used this for A? And the answer is yes, but I just at random chose this. So I'm going to choose vertex B here for this one. And then obviously this vertex and this vertex is adjacent, so I'm going to have to label this C. This will also be C because they're not adjacent to each other. So how many labels did I use? I used 3. Okay, the last one we're going to do is these ones over here. So I'm going to go ahead and label this group 1. Now I'm using numbers, which is okay. Is there anything that this is not adjacent to? Oh, it's this one right here. So that can also be group 1. But remember, once you use another group 1, you can't use another one. So let's figure out what the next one will be. All right, at random, this will be 2, and then this can be 2, and lastly, this will be 3. So the answer is 3 for this one here. Go ahead and pause the video and figure out the other two. Go ahead and pause it right now. Okay, there you have the other two there. And so the middle one was 3, and the other chromatic number was 2. And I'm sure you're going to have questions about this because it's, once again, it's a pretty simple concept, and there's really no set way to do it, so that's usually giving students the biggest problem. So please let me know if you have any questions, and I'll the next time you see me. All right, thank you for watching.